We spent the entire semester talking about the evolution of the Earth and its life forms, eventually getting to the present and Homo sapiens and our civilization. But where do we go from here? What's going to happen to our species and to the Earth? Some of the predictions of what the future of Earth and the solar system will be might be a little bit different with humans in the equation. What kind of technologies will we build, and what kind of effects will they have? This swerves into the realm of science fiction, but good science fiction has science in it. When we're talking about the future, of course, these are predictions and extrapolations, but it's all possible, and we'll use science fiction for comparison. Homo sapiens has been in existence for about 300,000 years, according to the latest findings. This number, not so long ago, was more like 200,000 years, but recent findings have pushed it back to 300,000 and possibly older. Here's Homo sapiens and other species of genus Homo. 300,000 years, and statistically speaking, it's possible for our species to last maybe a few million years. And so you can see some species last for quite some time. They have very good longevity, whereas other ones don't last very long at all. Whether it's hundreds of thousands of years or millions of years, it's quite a while to let evolution play out and for the next species to develop. The one thing about species of genus Homo is that most have developed tools and shown the ability to use them. And with Homo sapiens, we have very specialized tools. So why wait? Use those tools, our technology, to speed up the process, effectively rendering this species concept meaningless. So if that's the case, then where are we going? What is the next species of genus Homo going to be like? Will it have some superpower, some special ability? Will we call it Homo superior? So exactly what form will that species take? I think we're going to be finding that out sooner rather than later. One, either there is going to be no next species and Homo sapiens will go extinct as the last member of our genus will go extinct, or there will be another one. And either it'll be in hundreds of thousands or millions of years, or it'll be in hundreds or maybe a few thousand years. And what would that form be? When we talk about the future of humanity, and indeed the future of the Earth, really our technology is a primary factor. Our advanced technologies and have allowed Homo sapiens to do things other species on the planet have never done, affecting our environment in many different ways, altering natural events, not only changing climate for better or for worse, or deflecting asteroids, or any number of other changes and effects we can have. And with that power comes responsibility to use it in the right way. Proper application of this technology could mean no more bad days in terms of asteroid and comet impacts. It means possibly no more species going extinct. Could even mean new life of different types, whether it's synthetic or artificial, or no matter how you slice it, our technology is changing and is modifying our surroundings at an ever more rapid rate. Eventually, this progression of more and more advanced technology may even allow humans to not just change species, but to change form. And we call this transcendence. The ultimate in the evolution of a species, transcending its physical limitations. 2001: A Space Odyssey was a description of this process, from the primate stage through the Homo sapiens stage to the transcendent star child phase in the end. Technology gives us power to adapt to our environment, to partially control our environment, and thus control our destiny. no longer letting the course of natural events dictate our survival. We will be able to control these events and thus control our own path through the future. Let's talk about how technology will allow us to achieve these changes for our species. I call these changes adaptations. And one is genetic engineering, which just in the last few decades has seen immense progress, not only mapping out the DNA sequences of all sorts of organisms, but also being able to copy an organism via cloning. And we've done this with a number of different organisms, and human cloning is only a matter of time. Why is this? Why would we need to do this? One is the ends justify the means. There's some ultimate goal that we need to achieve, and this would make it possible. Could be fighting a war and we need troops, like in Star Wars. But really, one of the main drivers of this is because we can. Just the innate striving to do things that haven't been done, to figuring out answers to questions. This is what's driving our move forward with genetics. Really, it's what the Jurassic Park series was about. Having the ability to create and engineer different life forms, like this velociraptor with its genetic code displayed on its head there. It's pretty cool. The island of Dr. Moreau, of course, some unscrupulous scientist doing all sorts of genetic experiments because they can, not paying attention to any of the moral or legal issues. Genetic engineering is one way to change a species in many different ways, but there are many different issues with it too. All sorts of different unintended consequences and unforeseen consequences with genetic engineering and cloning. Instead of modifying the organism's DNA, we can actually combine the organism with an artificial control system, with machines. And this is the realm of cybernetics, the integration of biological and artificial control systems. That's a fancy way of saying putting organic with an inorganic. Artificial would be inorganic, and the result would be a cybernetic organism, or cyborg for short. Science fiction is replete with different examples of cyborgs, cybernetic organisms of all different kinds. There's the Borg, aptly named from Star Trek, where you can see the organism with the artificial control systems attached. Neo from the Matrix, mostly biological with implants that allow him to enter the Matrix. The Dune prequel series about the rise of the machines. Many of these have similar themes. Of course, Darth Vader is a cybernetic organism, part man, part machine. The Cylons of the reimagined Battlestar Galactica are part organic and part machine, and it's interesting because with them, they aren't human, but they are biological and artificial, so technically they are cybernetic organisms too. Ridley Scott, who produced the original Blade Runner, he says, yes, of course, Harrison Ford, Rick Deckard in Blade Runner was a replicant, a cyborg, and that's an open question that people debate. Of course, there's the early Jean-Claude Van Damme flick called Cyborg. Classic. So we've just reviewed ways in which technology can advance our species. But what kind of civilization would they live in? A man named Nikolai Kardashev is a Soviet astrophysicist. Back in the 50s and 60s, tried to quantify different civilization types. And his work was then taken by another astrophysicist named Michio Kaku, and he popularized the ideas of Kardashev. Basically, it's this. You can rank civilizations in an order, type 0 to type 1 to type 2, etc., based upon their energy output or their capacity to harness energy. A type 1 civilization would be able to control the total energy on a planetary scale. A Type 2 civilization would be a solar scale civilization, where you could harness the energy of a star. A Type 3 civilization harness the energy of billions of stars, a galaxy. So it's kind of an exponential increase. So this is one way of classifying it. It's a very scientific classification. There's no mention of any kind of details about the civilization, because any kind of predictions like that are prone to failure. To predict any specific technologies is fun, but it's not very scientific. It's more just a fun game. So Nikolai stuck with the science and basic energy. This kind of civilization, it's for other people like Kaku or like me to fill in the blanks with what kind of technologies those kind of civilizations would have at their disposal. And that's what I'm going to do now. But it's basically this progression from planetary civilization to a solar civilization to a galactic civilization that will probably follow. One last thing here. Predictions about the future, which are bound to be wrong. That is a major point that Michael Crichton has given in many different lectures and talks about the impossibility of prediction of the future. Let's look at these so-called Kardashev civilizations. Now his scale started with Type 1. And Carl Sagan looked at that and said, well, are we a Type 1 civilization right now here on Earth? Definitely not. So we're less than a Type 1. So he came up with the idea of a Type 0. So all the way from basically burning dung and burning wood, all the way up to just about controlling the energy of a planet would be a Type 0. So beginning to tap the energy resources on a planet, and this could be burning wood for energy, could be fossil fuels, tapping these resources, but really lacking the technology to control them totally. Like wind power, we can harness the energy from wind, but we can't control the wind. An F5 tornado has an immense amount of energy in it, as does a hurricane. We certainly can't control it. So Type 0 civilization derives most of its energy needs from what are called fossil fuels. And these are organic-based fuels, have an organic origin, like oil, coal, natural gas, fossil fuels. It's kind of an unfortunate descriptive name, fossil fuels. But there are certain fuels based on hydrocarbons, oil, coal, natural gas, definitely have organic origins. But you can also have abiotic oil or natural gas. Abiotic meaning there's no biological origins, it's inorganic. We use our technology to explore the solar system, and we do this with chemically powered devices. Here's a Type 0 way to get into space. Basically, fill a container full of highly toxic and flammable liquid and strap the primate on top, light the candle and set it off and hope it goes in the right direction. That's human space flight today. Chemically powered exploration. Sagan looked at what we're doing on the planet now and tried to estimate exactly where we are between Type 0 and Type 1. He knows we're more advanced than a Type 0.0, but not quite at Type 1 yet. He figured that we were using a certain percentage of the planet's energy, and it's only a fraction of the available energy resources on the planet, 16% or so. So he calculated we are 0.72. If you extrapolate this into the future, will it ever get to Type 1? And that is speculative. Well, a Type 0 civilization is on its way to becoming a planetary civilization. Just starting to figure out that it has power and how to use it. But this is a dangerous time because it's extremely vulnerable to a number of different threats. Some of the most dangerous are threats that it brings upon itself. And in our case, human-caused threats include many different kinds of problems. So adverse effects of biotechnology, nanotechnology, pandemics, both human-engineered and natural. Artificial intelligence may end up becoming a serious threat. Nuclear war has always been looming out there. It was always trendy no pun intended, back in the 60s and 70s to produce graphs like this, which would show the consumption of various resources, life expectancy and population and pollution and all that kind of stuff. And the similarity with all these kinds of graphs is by about the year 2000 is when we would either be peaking or we'd be running out. Things would start to go wrong in the 21st century, and books were written about this. Sci-fi was written about this. Of course, Soylent Green, about overpopulation. We know what Soylent Green is, of course. I Am Legend, about pandemics, and that's really biotechnology turning into a pandemic. AI being the Terminator series, and that includes nuclear war too. All these different issues. So this transition from type 0 to type 1 is the riskiest part of a civilization's evolution. This is where self-destruction really has the biggest chance of happening. Of course, things like this are always exaggerated. These curves are never proven to be correct. We're supposed to be running out of oil, peak oil, and coming down, and it's doing nothing but increasing. We keep finding new reservoirs of hydrocarbons, oil, and natural gas. Every year we find more and bigger ones. These predictions, again, are fraught with inaccuracy and ultimately failure. However, it doesn't get around the fact that this period for a civilization is a risky one. Well, if there weren't enough threats that we could bring on ourselves, there are also external threats to our civilization. And these include extraterrestrial sources like asteroid and comet impacts. These happen periodically. It's just a matter of time, just a matter of how big as well. We are getting impacts every day from space. It's just a matter of where they are and how big they are. Most happen over the ocean. Most happen in places where nobody ever sees them, and we might find the meteorite or crater later. But almost all of them are so small as to either avoid detection or they pose no serious risk. Every once in a while, though, we will be visited, which will leave some kind of impact. Like a few years ago in Russia, the Chelyabinsk asteroid or comet, which exploded high in the atmosphere, but the shock wave actually had an effect on the ground. Of course, there's 1908 Tunguska, same part of the world, which had a devastating effect. We can determine the hazard level of various asteroids and comets using this Torino impact scale. It goes from 0 to 10, with 0 being no threat whatsoever to 10 being a certain impact. It's just like an earthquake scale or a hurricane scale or anything like that. It's a hierarchy, and it progresses to more and more probable impacts, and the effects are greater and greater. No known asteroid, no asteroid we know today, is rated above a 0 on this scale. Nor has there ever been one rated above this, albeit once. The asteroid 99942, Apophis, which is about a 1/4 kilometer in diameter asteroid, was originally rated as a 4 on this scale. After one orbit, it was determined that there was a possibility of collision with the Earth in a few decades. And after a few more orbits, we refined the calculation and saw that it was no threat at all, and so it was downgraded to a 0. So it holds the distinction of being the only object to have been ranked on the scale to date. It is the Apophis asteroid used in the video game Rage as the agent of destruction, which set the landscape for that video game, which is kind of interesting. But it never panned out. And we found all the big asteroids and mapped them out. Of course, there's always new ones coming out of the blue that we haven't seen before, but they're relatively small. Small on a planetary scale, not small if it lands on your house. Of course, we can have natural threats like supervolcano eruptions. They happen on a higher frequency than flood basalts, and they can devastate regions, alter global climate. Of course, Yellowstone would be one to think about now in terms of one which is active, and we are technically overdue for an eruption. So this is a threat to our type 0 civilization. Bottom line with these threats is we better get through type 0 real quick and get on to type 1, where we're not as vulnerable to these kind of things. Did I say we needed to get to type 1? I think I did. Well, here we are. Type 1 Kardashev civilization can control the energy resources of an entire planet. And this includes controlling the weather, not just extracting energy from hurricanes and stuff like that, but actually weather modification and control. Seismic energy, controlling earthquakes. Deep crustal mining, pulling minerals from the crust, and also geothermal energy. Energy from the oceans, all different aspects of energy resources that a planet can provide, we can take advantage of. This is a definition of a type 1 civilization. In terms of energy sources, would probably mean at this point we developed the technology to harness fusion energy, which we're just starting to do now, and we can do so for very minute lengths of time, but it's not a practical way to produce energy right now. Right now we use fission power, which is nuclear power, which is splitting atoms, and we can control that process fairly well. But fusion power involves not splitting atoms, but putting them together, and that unleashes much more energy than with fission. And it's much harder to contain that. It's like unleashing the core of the sun in a laboratory. And so things like the tokamak and other different fusion devices try to use magnetic fields to bottle up the energy. And to this point, we haven't been successful in doing that. Antimatter exists. We have produced antimatter in various labs, super colliders. We've produced antiparticles. Positrons and electrons are an example of a positive and negative version of the same particle. But the amounts that we've produced are so exceedingly small that they couldn't power much more than a light bulb, much less the Starship Enterprise, which supposedly gets on with antimatter. We haven't gotten to that point. So as with a lot of science fiction, a lot of it is technically possible, but practically impossible. Solar power, not just solar panels on your roof and not just solar panel farms, probably orbital solar platforms which concentrate and then relay energy down to the surface. Structures of a type 1 civilization would be your true mega structure kind of thing. This would include like space elevators. Instead of sending humans into space with chemical powered rockets, we could use a space elevator to transfer people and material into orbit. Terraforming other planets and moons might be possible during a type 1 civilization, terraforming them to more of a habitable environment. Artificial intelligence would be in use. In fact, it already is in type 0 civilization, but in widespread use and much more advanced. And things called von Neumann probes, which are interesting. Von Neumann probes like this from the movie, is that Oblivion? I think it is Tom Cruise movie. Yeah, anyway, that's a von Neumann probe, which is one example. A von Neumann probe like the one at the beginning of 2001 Space Odyssey, or even the ones in the Dune novels. These are artificially intelligent spacecraft which are launched to different places, which then land and basically set up a factory and start making replicas of themselves, which they then launch to other places. And so very quickly you get an exponential development of probes, which then go off into different places that will be able to very quickly and efficiently explore faraway places. So that's a von Neumann probe. Onwards to type 2. And a type 2 civilization can control the power of its parent star. So this is a huge leap forward in development. And in this kind of civilization, the structures that would be built to harness a star's energy would, by definition, have to be huge. And the resources that would be needed to make these structures would be almost unimaginable. We would probably have to mine certain moons out of existence to get the raw materials necessary to make structures this big. But people started thinking about this. In 1970, Larry Niven wrote the book Ringworld, and it's about having a ring structure the distance from the sun that the Earth's is. So that's the Earth's orbit there, and it's this giant ring, and it has big walls on the side to keep everything from spilling off, and it's rotating, so there's gravity. but it basically is increasing the livable surface area millions of times greater than the Earth. There'd be shadow panels farther inward, which would block the sunlight, which would give you the day-night variations. That's a ring world, a giant structure. Well, this was taken and written about by Niven, but there were others that were thinking about this. In the 30s, there were science fiction authors that were thinking about these structures, but really it was in the 50s, and Freeman Dyson said, well, why stop at the ring? If you want to harness the full energy of the star, you have to encapsulate it in a sphere. And so he came up with the idea of a Dyson sphere. The first types were just individual panels, which would all be separate and individual, but they would be oriented in a spherical pattern around the star. But a type 2 Dyson sphere is actually the solid shell form like this. So you wouldn't actually see the star because it's enclosed in a solid sphere. Well, this takes the ring world concept and magnifies it a whole bunch. The problem with the Dyson sphere is capturing all the available energy from the star, but then you're going to generate a huge amount of heat that needs to be exhausted. If we ever figure that out, then maybe we can think about building a Dyson sphere, getting the raw materials, figuring out how to build such a thing and how to get rid of all that excess heat. Then, we can talk. But maybe a civilization's already done this, and it's something that the Search for Extraterrestrial Intelligence, SETI, they have thought about this, and they said, well, if Dyson spheres exist, we're not going to see the star, but we will see the heat signature. And if we see a heat signature, but we don't actually see a star at that position, then maybe it's a Dyson sphere. And they've actually looked for such things. One last thing about ring worlds. These aren't like the Halo universe rings. Those are just free-floating rings that are in orbit around a planet. Nothing like the solar system scale ring worlds. We've probably got to the point in technology where we're mastering gravitation and the speed of light, and we're traveling to different star systems. And there's a whole bunch of sci-fi about this. Asimov's Foundation talks about the transition to Type 2. There's Star Wars, there's Halo and the Forerunners, all different kinds of science fiction, which describe these different Type 0, Type 1, Type 2 civilizations. It's just when the authors wrote their books, they never thought in terms of Kardashev civilizations. And here's a totally gratuitous slide with Type 1 and 2 examples in sci-fi. Of course, there's Star Trek, Star Wars, Dune. So somewhere in the Type 1, Type 2 realm would be where Star Trek and Star Wars and Dune all live. Okay, so Type 1, Type 2, Type 3. Yes, now it starts to get weird. Type 3 civilization can control the power of an entire galaxy. So our star is one star. A galaxy like the Milky Way has hundreds of billions of stars, so 200 to 400 billion stars. So it's inconceivable how that would happen, what kind of civilization would exist to be able to do that. Probably mastered all sorts of physical laws that we know of and don't know of, Einstein's equations, space-time manipulation at will. In 2001, Space Odyssey, the end of the movie was a transcendent being. Of course, in Star Trek, the Type 3 being would be the Q. Snap your fingers, you go away, you come back, you can manipulate things at will. You would have to be able to do that to control the energy of a galaxy. So, true non-corporeal beings is what a Type 3 civilization would be like. So I don't even want to talk about Type 4. Type 3 is advanced enough. Some final thoughts on this subject. The climb from a Type 0, where we are today, to eventually a Type 1 and Type 2 and Type 3 is not linear, it's exponential. So the amount of time it took for us to go from Type 0.0 to 0.7 is hundreds of thousands of years. But the time it'll take us to go from where we are now to type 1, maybe a few hundred years. Certainly less than a few thousand years. So the farther we advance, the quicker those advancements will come. 3 million years or so, we went from ape-like, Australopithecines, there was no genus Homo yet, to a global civilization. So our earliest, closest ancestors, the Australopithecines, about 3 million years ago, then genus Homo kicked in, been around a few million years and still at type 0. And that was one of the themes of 2001: A Space Odyssey here at the beginning of the movie, the primates around the type 3 von Neumann probe. So right there you have juxtaposition of two different levels of being. From that to global civilization, about 3 million years to what we have today. It's thought that to reach type 1, Freeman Dyson has given this some thought, and maybe a few centuries. I'll be more conservative and call it 1,000 years. So by the year 3000, we should be at type 1. Most of the science fiction you watch, and you look at the timelines, Blade Runner was the year 2019, and it's like, what? So you really have to expand the timeline out a little bit to be a little bit more realistic. But I think 1,000 years to reach type 1 is realistic. And then a few thousand years of exploring the solar system and of exploring our solar neighborhood, building a galactic civilization, that's going to be on the order of thousands of years, not millions of years. The advancements will be coming at greater frequencies. So eventually getting to the point of transcendence and all that. Yes, the final slide of the semester. Let's just wrap this up and talk about Frank Drake. He was a co-founder of SETI, the Search for Extraterrestrial Intelligence. Before that, it was named something else. But his claim to fame really is an equation that he came up with that tries to quantify the number of extraterrestrial civilizations in a galaxy. And it's called the Drake equation. And here it is, 7 variables in this version here, where n is the number of technologically advanced civilizations, r is the rate of formation of stars in the galaxy, fp is the fraction of stars with planetary systems. We can make a decent guess with that. And we find a lot of stars have planetary systems, so it's probably a significant fraction. Ne, the number of planets with environments suitable for life. Just because a planet's in a habitable zone doesn't mean it's suitable for life. That's a big if. Fraction of suitable planets where life actually appears. Who knows? We can say, yeah, life should appear, but who really knows? Fraction of life-bearing planets with intelligent life. That's even less knowable. Fraction of civilizations that develop a technology that releases detectable signs of its existence. So basically, radio communication or something like that. I don't know. The length of time a civilization is detectable with these signals. So how long does a civilization transmit these signals? How long does a civilization last? In terms of our civilization, we have been emanating radio signals into space for 100 years. At first, very weak signals diffusing out into space. In the past few decades, we've had actual focused transmissions aimed at certain stars where we're trying to communicate, hey, we're here. But it's only in the last 100 years. It's a very short period of time. Earth is the only planet where we know all these variables add up to a civilization. Most of these variables, some of them we can estimate more clearly. Some of them are much more difficult. Some of them are just downright unknowable. They'd just be a guess. That's the problem with the Drake equation, is that it's a nice thought exercise, but it's not really definitive. Well, we end with the physicist Enrico Fermi, and it was on a visit to Los Alamos in the 50s where him and some colleagues were having lunch, and he just asked the question, where are they? To paraphrase, if extraterrestrial life should be abundant, then why haven't we found it? where are they? And that is the Fermi paradox. So there's a couple answers to this. The universe is a big place. If there are other intelligent civilizations, we are separated by vast distances. So vast that a radio signal leaving the other edge of the Milky Way galaxy 100,000 years ago would just be getting here today. That means that that civilization would be 100,000 years ahead of us in evolution. The universe is very old. It's billions of years old. Civilization, a few million years to go from apes to now, and then maybe a few 100,000 years more to get to type 2 or something. So a few million years and you've gone through that transcendence if you can do it. The universe is 13.8 billion years old. And not all of that time it was really habitable, but even if all life was just in the last billion years in the universe, we still could have civilizations that have risen and fallen long before we ever existed. There have been stars that have formed and lived and exploded long before the sun ever formed. In fact, that's why we're here, is because the elements that create the Earth, they were made inside a star that blew up long ago. Maybe the alien life's out there. We just don't recognize them. They're here, it's just we don't recognize them. And then, of course, maybe they're out there, maybe they hear us, but maybe they don't want to talk to us. Maybe they don't want to be found. Maybe they want to keep their Type 3 secrets to themselves. Maybe they have that Star Trek non-interference prime directive. Whatever the reason is, it all adds up to a big zero. We found nothing, and it's not surprising because we will find planets and even habitable planets, and we're finding them now with exoplanet searches. But finding each one of these variables in such a way that it satisfies development of life is a tall order. You have to have a number of things in alignment. It's almost a chance kind of thing. To end with this, the universe is so large, and there are enough stars in just the Milky Way alone, hundreds of billions, that the chances of there not being life out there is just, that's crazy. So life probably exists out there. The only question is it intelligent life, and does it exist now, or did it exist before? Has it gone extinct? Or is it out there and we don't recognize it? Or is it out there and they don't want to be found? We may never know. But I think someday we will.